Alrighty guys, we have made it to the end of our magnetism section, and we're going to finish off with magnetism notes part 4, electromagnets. So some of you might be asking, what is an electromagnet? Well, an electromagnet is just a temporary magnet that can be made by wrapping a wire or a coil carrying a current around an iron core. Looks something like this. You guys might have actually made one of these when you were younger in maybe middle school or elementary school, where we have a piece of iron over here, in this case just an iron nail, and then we have a battery, which is our power source, and then a wire that is wrapped from the top part of the battery, then wraps around this nail, and then touches the bottom part of the battery. That enables the current to flow from the positive part of the battery around this piece of iron and then back to the negative part of the battery. As the current flows through this wire, it's going to generate a magnetic field around the iron core. Here's just another picture of that, this time showing the magnetic field. So here's our current, and then we generate a magnetic field around this iron core. A solenoid is a single wire that is wrapped around a cylinder. So in other words, a electromagnet is a solenoid. The only difference is that a solenoid does not have a core. There is no iron core for a solenoid. A solenoid is just a single piece of wire that is wrapped around air in a cylindrical fashion. Where an electromagnet is a solenoid with a piece of iron in the middle. Let's talk about the properties of an electromagnet really quick. First property is that they are temporary. Okay, it is something that only works when current is flowing through it. So electromagnets are something that we can turn on and turn off as we want. Number 2 is that the strength of the magnet is increased by adding more loops of wire around that cylinder. So before we saw that picture of the nail and how it had that loop of wire around it, the more loops we put around that nail, the stronger the magnetic field will be. Number 3 is that it still has a north and south pole, and the reason being is that we're generating a magnetic field, and we know that a magnetic field is comprised of a north and south pole. It attracts other magnetic materials. So magnets attract magnets, we know that. So if we took our electromagnet, we would be able to pick up other magnets or magnetic materials with it. For instance, you guys have seen this at like junkyards where they have that giant electromagnet that attracts those cars. It picks them up and then they drop the cars. How do you think they drop them? Well, if we look at rule number 1 up here, the electromagnet is temporary. It only works when current flows through it. So they're able to drop those cars when they shut off the current. And lastly, number 5, so when current is turned on, the magnet may be attracted to other magnets. The movement can then be converted to mechanical energy to work. So this is just telling us how generators are able to work. So what types of things use electromagnets? Well, we talked about in the last slide, for instance, junkyard magnets use electromagnets, electric cars, doorbells, hospital MRI machines, that's magnetic resonance imaging, and a bunch of other objects use electromagnets. And here's just a picture of those in case you're unfamiliar. So this would be our MRI. This is our junkyard magnet. And then lastly, this is our magnetic train. And some of you guys may have heard of a maglev train. We don't have any as far as I know in the US at this time, but there are a few overseas. And we can go ahead and watch 1 or 2 of these videos really quickly to see how they work and why they're so important.